Hey guys, Mr. Gardner here with another quick lesson. This time I want to talk about how we can check coordinate pairs to see if they are a valid solution to our equation. So let's say we're given this equation y equals 2x and somebody says, is 2, 4 a valid solution for this equation? Now we got to remember this is an xy pair, coordinate pair. And so we can check this in a couple of ways. The first way we can check is we can just substitute the values in. So we know that this is our y value, so we just substitute that in for this y. So it gives me 4 equals, and I have 2 times x. X is 2 in this case, so 2 times 2. I'm going to evaluate that, and I get 4 equals 4. This is a true statement. 4 does indeed equal 4, which tells me that this coordinate pair is also a true statement because I checked it into the equation. All right, let's just look at what it would look like if maybe it didn't satisfy. So let's say we have 3, 7 is our coordinate points. Let's see if this satisfies our equation. So 7 for the y, 2 times 3 for our x. We evaluate that. We get 6 is equivalent to 7. This is not a true statement. 7 does not equal 6, which means this coordinate pair is not going to be valid. Okay, so that's one way. You just substitute the points in. You check for validity this way, seeing if it's true or not, true or false. Another way is you could graph the equation. So let's just quickly draw out, sketch a little graph real fast to take a peek at what this would look like. And we got a little whoopsie here. We'll just erase that. And so if we looked at this, let me just build a little table of values real fast. All right, and I'll put my x's here, my y's here, and I'll try 0, 1, and -1. And I know that 2 times 0 is going to give me 0, so there's that point there. And I know 2 times 1 is 2, and 2 times -1 is -2. So that's going to put me here and here. And so I'm going to try and connect these lines as nicely as possible. And going this way. Through there. I'll just put a little arrow on them. And so now that's the graph of this equation. So you can see if a point is valid by just checking on the graph. Well, this is 1, 2. So x is 2, y is 4. 1, 2, 3, 4. That point right there is indeed on my line. That also tells me that this is a true statement. And I can check this one now. 1, 2, 3, and then I go up 7. 1, 2, 3, 4, 5, 6, 7. That point is right there, which is not on my line. That tells me that that is not a valid point. So that's not going to work. So let's look at this one here. Let's say we're given something like x is 2, y is 19. Again, we can check this by just substituting in the values. So let's say y is 19 equals 6 times 2 plus 7. So again, 19 is not changing. We're going to evaluate this first because it's multiplication. So 12 plus 7. Okay, just bring that one down. Then 19 is the same. 12 plus 7 becomes 19. 19 and 19, this is a true statement. Again, we could graph this line out and check to see if this works. So we can do that really quick. So let's say I make a graph. This time I'm actually going to scale out my graph. So I'm going to call these 1s. And I'm going to call these 10s because you can see we're multiplying by 6 and adding 7. So we're going to jump up really fast. So doing it by 1s is going to not work. All right, so again, we can just check. What if let's just make a table of values. Let's do x, y. Let's do 0 first because 0 is always a good one to check. 6 times 0 is 0. Plus 7 makes this 7. So at 0 we have 7. So that's almost up to 10. All right, let's try 1. So if I have 1, 6 times 1 is 6, plus 7 makes 13. So I'm a little bit above 10 now, so I'll be about right there. And if we try -1, we should get -6 times 1. That's going to be -6, plus 7 is going to give us 1. So that's going to put us right about here, just a little over the 0 point. So that gives us this really kind of steep line here. And again, we can just check points along this line because any point that falls on this line is going to be a solution to this equation. So again, you could do 2 and 19, and I mean, my line's not perfect. It probably should have gone like right here, but you would see that that point is close enough onto the line that that is a solution. So those are two ways for checking solutions to equations.